My name is Christian Melendez. I work for Equinix in the professional services. We help companies in the onboard journey to have a better performance in their networking and hybrid clusters and applications in case they need to have interconnected environments. I also founded the user group in Guatemala, the Latin America group in Spanish, and I'm co-organizing the meetup in Madrid. So I have the opportunity to talk with a lot of members of the community. And every time that we talk about AWS, we learn something new, even the ones that are sharing their knowledge. But I also work for insurance consultancy company. We work for the top 5 insurance companies in the US. And the system that we were working for, it was about finding who should be paying the insurance claims that customers were doing, because there were times where users were putting some insurance claims there, and they needed to make sure who is the responsible of paying that. So we needed to not just react fast, but we have to be pretty sure if the information that we had there was accurate and was the one that we thought that is going to be useful for the company that was using our software. So it is not just about what fraud detection is a billion business nowadays, and is increasing every day. So it is an adaptive process that you need to continue learning, that you need to iterate, that you need to keep working on them. You cannot say that you're done with when you find out the fraud. You need to keep going, because there are going to be always new things or new ways to hack the system, as with everything, right? So let me take you through some theory, some concepts about fraud detection, and then we're gonna keep talking about how can you build fraud detection systems using AWS Batch and, of course, containers. So it is not about just banks, or it's not just about credit cards. There are other use cases where you can apply fraud detection. So let me see your hands. How many of you are working with fraud detection systems? Okay, cool. So you're with me, right? It is not just about banking. It is not just about credit cards or things like that. I've heard that if we have I heard a story that there's a company there that is using fraud detections for biking rentals, where they need to find out if someone is not trying to steal the bike or the scooter that they just rented, or if it's the person that they are going to rent the bike or the scooter is the person that is going to return that, right? So there are a lot of other use cases where you can apply fraud detection. So it is not just about credit cards or for banking. There are use cases where you don't need to react fast and promptly in real time, but you have to be really precise on what are your decisions on how to detect fraud. So fraud detection works better with structured data. When you have structured data, you can easily take decisions there, because you already have the information that you have. You have run some cleanup for the data. You have everything that you need there. So you're not going to be including any noise there. So it is better if you have structured data, because usually you take data or you read data from different sources. It is about a continuous learning. You cannot stop. You cannot stop there and say that you're done there. You need to continue finding new ways or understanding the data that you are collecting from all of your systems. It is not easy just because of that, because you cannot say that you're done. You need to continue finding new ways of to interpret the data that you are collecting with your systems. So, as I said before, you need to react fast and promptly, even though there are systems where you don't need to have that ability. But usually that's the concept, because remember that it is a 1 billion business nowadays, and it's increasing every day. So you need to react at the proper time, because if not, you're going to be losing a lot of money. So for fraud detection, there are 4 analysis methods that you can implement, or that you usually, or the industry usually applies to these type of systems. There are the knowledge discovery database, where you actually just collect the data that you are gonna be using. You just collect the data that you need, that you think that you're gonna need to build the rules or the algorithm that will detect that there is actually fraud in the data that you have. There's also the data mining process, where you need to find, where you are going to find patterns of the data that you are collecting. You're gonna, after you collected that data, you're gonna understand, you're gonna find out if there are some use cases or some data that you think that could look like a fraud. So there's also those type of analysis that you could be applying. And of course, once you are there, once you find out which are the patterns that you're gonna be applying or using, you have a machine that is going to be learning about how to, because you're gonna be having the base of the problem or the fraud, and you're gonna be using machine learning to continue adapting to that. There's also statistic methods where you're going to be using, for example, the average time of the number of insurance claims that people is doing and things like that. But those are just rules. Those are just numbers that if you don't give the information, or if you don't give them the purpose that you are trying to detect a fraud, they're going to be meaningless. So one of those examples where you need to apply statistic data analysis is, as we were talking before, you need to prepare or fix data. Usually that's the first process that you are actually going to run every time that you are collecting and treating with your data. It is not just like, it is not as simple sometimes as just extracting, transform, and loading ETL processes. Usually, you will need to implement more complex algorithms there, or more processes there. You're going to need to work with average number of requests. You're going to have to work with numbers. You're going to have to work with distributions. You have to work with percentiles and things like that. More information more different ways to interpret that data. You're going to need to have a cluster and classification. Every time that you have the data, you need to find out which data is going to be useful for what. So it is useful because you're going to be collecting data from all other sources. So it is useful it is helpful if you have that cluster and classification of the data. Finally, next, if you have that information there, you're going to be able to detect anomalies in the data that you are collecting, that your systems are collecting. And one of the ways, or the services that you could be using for AWS, AWS will offer you a lot of services where you can start applying these statistic data analysis methods. So you will have, for example, you traditionally would use AWS Lambda, EC2, Amazon Athena to query the data in a serverless way. You will have, you could be using Amazon Kinesis, for example, to process the data in real time. For storage, you will have, you could be using S3. And we're going to take a look to some few architecture ideas or few diagrams that I have for you here, where everything will make sense there. So how does all of these services looks like in action? Well, I wanted to use the example of a Lambda architecture, because I think that it represents very well what we are trying to achieve here with fraud detection. Because remember, there are going to be times where you're not going to be using only real-time data, or you're going to be just not processing data in real time and detect fraud. As soon as you have the data there, again, there are going to be systems where, like, for example, the insurance claims that I was talking before, they need to find out if, the record history from the customer, how good is he, how well is he doing on that, if it's not risky to pay that bill because he's been doing that for several times, for example. But even though we have a lot of these cool services, there's one service in particular there that we need to take care of, and those are EC2 instances. Even though this looks like we have a serverless architecture, we'll still have those type of problems, not problems, but you need to take care of that. And you usually will install there something to orchestrate the jobs, to orchestrate the tasks that will gonna help you to detect the fraud systems. So we're gonna take a look to that in a more detail in other slides. But let me talk to you about some usually open source tools that the industry is using, and I bet that maybe some of you are already using some of these tools. We have Apache SAMHSA, we have Spark, we have Apex, we have Apache Storm, and we have Apache Flink. Personally, I have used Apache Storm, and I started to use Apache Spark a few years ago when I was working with that company that I mentioned. And I find out that maybe it was because there were enough information for example, from Apache Spark, or maybe it wasn't that mature at that moment. But it was so hard to configure that. It was so hard. I mean, I spent up more time trying to understand the tool, trying to understand how to build something before I could actually do something. Before actually I could build the algorithm, build the decision tree that I was going to be using, or team were going to be using to detect the fraud that we were talking about. But even these type of tools, for example, I can speak for Apache Storm and Apache Spark. They are actually implementing the Lambda architecture. They have the batch processing layer, and they have the speed layer. So you could be applying Lambda architecture by using these type of tools, and Apache Spark is doing actually micro-batching processing. So the thing is that if these tools are actually doing that, why we shouldn't be doing using batch processing, right? So let's talk about a little bit about batch processing and where I think, or where I've seen that where you need still to apply batch processing, even though you have now machine learning, even though you have now real-time data. There is a time, there is a moment where you still need to have to keep working with batch processing. So, but maybe instead of saying just you need to, or there are some cases, let me show you some of the things that usually you need to keep doing with, to do with batch processing. The first thing that you need to, if you are already working with fraud detection systems, you know that there is also pre-work needed. And especially for this type of technologies where you have at least once delivery. One example of that was the first version of the AWS SQS, where they didn't guarantee you the order, not just the order, but they say that it doesn't, at least we're gonna deliver once the message to the queue. And I had this problem also with Kinesis, where I needed to run a batch processing job to clean up the data, because there were times that I have duplicated data. And duplicated data, when you are trying to understand patterns and things like that, is just noise. You need to get rid of that. You need to work for that. So just by having this problem, at least once delivery, now you could say that I need to have something to get rid of that, to process that. So start with batch processing. Don't worry if you are not, if you think that even if you are working with projects or industries where actually machine learning and fraud detection, and real-time processes are gonna be needed because you need to react fast and promptly, start with batch processing. You need to understand first. Complex analysis will need more data, like I was saying before with the example of the insurance claims, where usually they need to review other type of information before actually giving a response to the customer. So there are going to be complex analyses where different type of sources need to be consulted. High accuracy first, then learn how fraud detection looks like. This is gonna be the advice that I'm gonna present for you throughout this talk, and why you need to have to start using batch processing, because as I said before, there are gonna be use cases where you need to be to have the level of accuracy that you're gonna need is higher than the speed that you're gonna be needing to process the data. So you're going to also be able to test multiple hypotheses. At the same time, you're going to be able to run A/B tests. You're going to be able to, even if you already have something running, you could be applying even some techniques that you usually use for continuous delivery deployments, for example. You could be using a blue-green deployments and things like that. But because you are already using one source for the data, to collect the data and to work with and trying to detect a fraud, you're going to be able to test multiple hypotheses. And because of that, we're going to take a look to which are the techniques and the technologies that you could be using for that. So you'll also be able to troubleshoot by going back in time. So all of these actions and all of these processes that you actually need when working with batch processing are going to be included in this service, AWS Batch. But again, you're going to still be needing real-time machine learning processes. So what should we be doing now then? Well, to work with AWS Batch, you need to start with what you already have. You don't have to worry about recreating everything. You don't have to worry about working with the scheduler. You just need to focus on what you are developing. And we're going to take a look. We're going to take a recap to what AWS Batch is in case you are not aware of it. But I want to share with you some techniques or some strategies that usually come from the development side of the development world, where I've find those techniques really useful. So in order to work with batch processing, and if you are going to do the transition to machine learning processes, try to use some patterns and do not try, avoid the temptation of getting rid of what you already have and forget about that and try to deliver something new and work with a greenfield project. For example, you could start working, or you continue working with your brownfield project, right? So in order to do that, you could use the strangle pattern, which is the pattern commonly used in the development industry, where you will be building the new version of the system around the edges of the old system. And at some point, you will strangle the old system, but you're going to be that in an iterative process. So you could be you could easily start using batch processing and go to machine learning, but by doing that step by step. So what you're going to be doing is that you're going to keep doing what you're doing. You're going to continue using what you already have. You're going to continue using the processes that you already have there. For example, usually you will have, the simplest way to run a batch processing job is by having a cron job, for example. So you could be keep using that part, but we're going to get rid of the problems of scaling by using this type of services. And as I said before, you're going to be able to run tests in parallel, seeing data streams. In case you are going to, you decide to continue working with what you have with batch processing, you're going to be able to stream the data to something else and work with machine learning processes. Run A/B testing, as I was saying before too, and you're going to be able to compare the results so that later you can refine and choose the best option or the best decision tree that you will be using for your fraud detection algorithms. So continue with the topic, we have containers. So the title of the topic included AWS Batch with containers. And I'm not including containers just because everybody is talking about containers, so or everybody is saying that containers are cool and we should be using containers for everything. That's not the case here. I want to explain with you why I think for this type of problems, for fraud detection algorithms, containers are a really good option, and especially when we're working with batch processing. With containers, you will be able to have everything that you might already know about having isolation processes, having being able to run what you already have in your computer, in another computer, in another environment. But what is useful in this case is that you could use containers by reusing what you already have. And again, we're just applying the same principles that we learned or that the industry learned from the development processes or strategies to work with containers. So I'm not sure if you are familiar with design patterns in software development, but there's a book that Brendan Borst, the co-founder of Kubernetes, wrote a few months ago, where he's talking about container design patterns. And one of the patterns that you will find there is the work queue pattern. And I found that interesting because when working with the work queue or batch processing, this is the simplest way, the simplest solution or perspective that you could be using to solve a batch processing problem. And this is going to be covering just like the general conception of work queue pattern, which is really simple, right? So you will have there work items that are going to be sent to the work queue manager, and that work queue manager is going to be able to, or the purpose of that work queue manager is to schedule those work items into workers that are going to be processing the data in parallel. So as simple as that. But the thing is that you could be using this pattern to reduce and to split the problem in smaller problems, a big problem in smaller problems, by starting to solve little by little. So the first section that we're going to be abstracting or removing from that diagram that you're seeing here is the work queue manager. So with containers, you will be able to work with every box, the two boxes that you see there, each of them is a container image or container instance, for example. And the work queue manager container will be something that you will build for a generic solution. That will be, for example, an API endpoint that your applications will consume. And it doesn't matter what you have underneath that solution or that implementation, the software that is using the work queue or the queue system, it's going to be agnostic for them. So think of it like this will be an interface if you are used to software development terms. The other container is going to be the implementation of that interface. So what you will have here is that you don't need to break the interface, you don't need to break the contract every time that you need to change something in the implementation of the queue pattern. So for example, in case you need to change the engine of the queue or the solution or the tool that you're using for the queue system, that could be, for example, AWS SQS, Kinesis, or it could be RabbitMQ, it doesn't matter. You're going to be able to create a reusable image or a reusable endpoint in the first container that you see here that you could be using in other places of the system. And then you will be able to, by using another pattern, the ambassador pattern, create the implementation of that solution. But that's the first part. That's like the queue manager, and that could be everything as you need to use. The other section is the worker item, which is I would say that this is the most important part of the pattern, where you need to create a container that will be able to process the data or the work items that you are receiving in your system. So these type of problems, for example, when you're working with containers and by using this pattern, the interesting thing here is that if you think in advance that you're going to be using these type of systems, and trust me, I must say that because I've seen that when developers or when other companies are creating these type of solutions, they don't think ahead about when you are working with batch processing, you need to be able to parallelize workers. And with containers, you could be able to run something pretty standard, and that you could be changing by changing the environment variables, for example. And you're going to be able to change the behavior of the container based on that configuration. So even though it sounds really simple, I've seen that not many companies or not many people is applying this principle of having parallel workers. And with containers, you're going to be building just one image, just that. When you think about that, you're going to be, you could be saying, I need to work in parallel for these processes. So I need to build a scheduler. I need to build something that is going to be able to process that in parallel. But with containers, you're going to be able to just focus on that. And it doesn't matter how many times you need to run processes like, or tools or services like AWS Batch or the Queue Manager will be able to take care of that. And that's basically the pattern that I wanted to share with you. And this type of patterns or this type of problems were, it's not something new. AWS also had the diagram of how to work with batch processing with the technologies that they had at the moment. Remember that I was talking before about using EC2, AWS Lambda, and things like that. So a long time ago, they had these type of architectures where you're going to be using EC2 instances. You're going to be scaling based on the work items that you have in the queue with your auto-scaling groups. But you needed to keep work. It was your responsibility to take care of everything there. So you can see there that there are a lot of pieces there that you need to take care before actually doing something, actually trying to run batch jobs at scale. So for that, we have we have this option now of AWS Batch. Just in case I mentioned this before, just in case you're not aware of what AWS Batch is, let's do a recap. Because even though it sounds like really simple, it is a really powerful tool there, a service there. First thing is that AWS Batch is a free managed job scheduler. You don't pay anything for using AWS Batch. What's under the hood of AWS Batch is ECS. And if you are already working with ECS, you will find this type of services very helpful. And the learning curve is not that big, even though the documentation is still growing. There are a lot of other blog posts out there, and there are a lot of other companies that are already using AWS Batch, and they are working in tools or wrapper of things that are actually making these type of services even better. You are able to launch EC2 instances when you need. This is like a big catch for AWS Batch, because remember that I was saying in the diagram that we were seeing before, you had the auto-scaling groups that they were growing based on the work items that you have in the queue. Well, AWS Batch will grow at the scale that you need based on the work items or the jobs that you are submitting to the service. So you don't need to worry about that. Even if you need to have customized AMIs, or that if you need to install something, or if you need to use EFS file system, for example, you could customize that part. So AWS Batch will launch the instances that you need. And the good thing is that when the workers are done with processing the work items, AWS Batch will turn off those instances. And AWS Batch can decide which type of instances are going to be using based on the containers that you are configuring in the service. Because of that, AWS Batch is aware or knows how many instances you're going to be needing on the memory or the CPU reservation that you had for that container. If you are worried about how to save some money, you could also be using spot instances there. But again, this sounds like it is something new, or is something like we didn't have that before. But because this is under the hood, AWS Batch is using ECS. We already had that with that service. So even though it is cool, the AWS Batch is just a wrapper or they are offering you a new way of working with batch processing, because all of these type of tasks, you could be creating that in ECS, right? But AWS Batch is just another layer. So you just need to learn how to use it. It is integrated because it is integrated with ECS. It is integrated with VPC, so you could be working perfectly in a private environment there. You don't need to worry about that. This is going to be used outside of your network, and because when we are talking about fraud detection, this is pretty important that the information that you have there is not is not public by mistake. The cool thing is also that you have multiple job queues with priorities. You could be configuring complex environments there where you could be using, for a certain type of queue, you could be configuring use these on-demand instances, and for another queue for your free tier users, for example, or for the hypothesis or the A/B test that you're running, use spot instances, for example, because you are just trying to see how everything works. So you could be using multiple job queues there with priorities, and each queue will have a different instance type. And there are some gotchas that I want to share with you, because the first time that I used this service, these gotchas weren't that obvious for me, and I found that really useful, that if someone could have shared that with me before, I think that I could be having a cluster, AWS Batch cluster running in minutes. The first thing is that, and the most important, I would say, is that in compute resources, vCPUs is not the same as CPU units. And because I have the theory of AWS Batch is similar to ECS, the first thing that I thought that when I was configuring the job definition, which is like a ECS task definition, I thought that, well, for compute resources, it's the same, right? I'm going to configure how many vCPU units, CPU units I needed for the container, but it's not the same. So in compute resources, the vCPU use is actually the virtual CPUs that you're going to be needing for that cluster. So you just define that. In job definitions, do not use CPU units, because, again, even though it is a task definition in ECS, it is not using CPU units. Because if you end up doing that, you're going to your jobs have states, and your jobs are going to be stick in the runnable state, and you're going to see that, and you're going to wonder why it's not running, why it's not working. And trust me, as it sounds really simple, this is if I have that, if I have had that before, that will be really helpful. The trigger for the queue or for the system is submitting a job call, and it is pretty straightforward. This is an example of how you will submit a job. You could integrate that in your existing workload. You could be creating, for example, the container implementation of the container interface or the resource that you are using. You could be using any SDK that AWS supports. And the cool thing, because you have this, other companies are creating support for AWS Batch or other projects like Pegasus WMS or the project that Spotify launched called Luigi. They already include support for AWS Batch by using this. So there are examples out there that where you could see how AWS Batch integrates with this type of frameworks out there. So let me show you a few architecture ideas on how can you start working with that, because remember that we were already seeing that, and it is pretty straightforward. Sadly, I cannot share with you the names of any company, because fraud detection is like really sensitive. Not anyone. I mean, there are a few companies that are willing to share that information. So I cannot get into the details, but I wanted to share with you some architecture ideas where you can apply this type of processes, and where you can use that you could be using with other AWS services. So traditional batch processing with containers will look like this. You will have your users there that are going to be hitting the environment or the resources that you have in the cloud. And the first thing, for example, that you could decide that you're going to be using AWS Kinesis. And with Kinesis, you could be having the batch layer, and with an AWS Lambda, you could be reading or consuming that data in a micro-batching way. But the difference is that because previously you had the timeout of Lambda functions of 5 minutes, now you have 15 minutes there. But at some point you will always have a limit. It doesn't matter how much time you have there. Even if there's a request that AWS Lambda could support more time, there are going to be always in batch processing things where you will need more time, where you will need that based on the work item that will scale. And even though you have a way to manage those limits in AWS Lambda, there's going to be always a limit. So you could be using AWS Lambda as a proxy to AWS Batch. And this is just an example, of course, where what you can use to interact with AWS Batch. Then the AWS Lambda will launch the submit job call to AWS Batch. And AWS Batch will basically receive everything that you send. It doesn't matter how much or how many requests you send to AWS Batch. AWS Batch will receive that, and based on the work on the load that it receives, it will create the actual resource, the EC2 resources there, based on the configuration that you previously had or had to create when you were creating the service. So, for example, it will create 3 instances, 4 instances, and if you configure everything correctly, it will start launching the instances. If not, AWS Batch, for example, will verify that you don't have a soft limit of how many EC2 instances your account can launch. But because if you didn't configure that correctly, AWS could end up saying that it will need 100 instances because of the workload that you are sending at the moment. And I know that it sounds like AWS Batch won't be, it scales dynamically. You need to be very careful on that part because the first set of jobs that you send, if you didn't configure that correctly, AWS Batch will just have those jobs there. And even though AWS Batch offers a retry option there are going to be some times where it's not going to work. So then after you have the compute resources running, you could be sending that data to AWS to Amazon S3, for example, and you could be connecting the other AWS services with that. You could be having S3 bucket where you are just sending everything for a couple purposes there. You could be using the first bucket to have temporary data there and things like that. And then the data that you have there, you will be using something like Amazon Athena and Amazon QuickSight to review that data. So even though that looks like not that simple as it should be something, the secret sauce here is what you have in your containers. AWS Batch will take care of that, and it is pretty much a serverless architecture. So let's take a look at something, if you similar architecture, if you want to include the real-time layer, for example. Because remember that we were talking about the Lambda architecture, not AWS Lambda. And we were also working about the strangler pattern. So again, you will have your users here, you will have your cloud here, and you will send that to Amazon Kinesis. And again, the difference will be that you will have the same as the previous one. You will have your batch layer, but now you will have your speed layer. So this is where the cool thing is, because you could be using another AWS Lambda to run another set of tests by consuming the data that is arriving to Kinesis, and you're going to be able to process that. And the same thing that you could be doing for the speed layer, you could be doing that for the batch layer. So it doesn't matter how many experiments you would like to run, but just using this type of services and taking care of the container or the solution that you have, it will be enough. So again, you will be then connecting that with Amazon S3, and you will be able to connect that with another services like Kinesis Data Firehouse, for example, if you want to send that data to S3 or Redshift. And again, the same as the previous one, you will have something that will collect the unified information, and you will be consuming that with Athena and graphically with QuickSight. So it looks like really simple, but this is like the solution that will work with if you are trying to move from batch processing to machine learning algorithms. And in case you are wondering how to focus only in machine learning algorithms, you could be working with, again, with Kinesis. You will have the Lambda here. And then you will have Batch. And Batch will launch EC2 resources. And the cool thing about Batch is that you could be working with these simple scenarios, but you could also work with array jobs where you could create complex logic or complex processes there, where one container will be in charge of executing one phase of the pipeline that you need to run for processing the data, for example. So in that example is using, the first group will be a container, just the container for the step 1. And the second one will be the container for the step 2 and things like that. And then you could create the data the structured data that you're going to be using for your machine learning algorithms, and another services like SageMaker could be consuming that data. So you will be, you won't include the data preparation in SageMaker, even though it is possible to do that. You could split the problems in different sections by using AWS Batch and by using containers. So wrapping up, learn how fraud looks. You need to understand that first in order to take a better decision. You need to understand the data, and batch processing is gonna be the starting point for that. Batch processing is still needed, or there are some cases where actually batch processing is the only way. So if that's your case, and if you are okay by actually doing something and starting with something, you could be using AWS Batch for that matter. You will be able to simultaneously run batch, real-time, and machine learning and create more complex scenarios. But again, batch processing and AWS Batch will be the starting point for that. Don't reinvent the wheel. Use AWS Batch or managed services or serverless services that you have in AWS Batch. Even though that some tools are really cool, like the tools that I mentioned before, do not try to get complex at the beginning, even though if you need to do it, start simple, because the more interactive that you do that process, the better it will be for you to start learning and improving the solution. And again, containers will help you to reduce the lead time. And just because you are working with, if you you think ahead about the patterns and think ahead that you're going to be using that to run multiple times, containers and AWS Batch will be the solution for you to reduce the lead time, because that will be just a matter of pushing the new container version, and you don't have to change anything in the job definition. You could be creating another queue in AWS Batch that will be using that job definition of the container image. And you could be, again, applying the same principles of blue-green deployments, canary releases, and things like that have worked for continuous delivery pipelines. You could be applying the same principles when you are working with containers and AWS Batch. Lastly, learn, adapt, and try again. So that was all. Thank you. Have a great time.